This conference will now be recorded.
Okay, so good morning all and welcome back to the session. This is Big Data Masters Programmer. So previously we have discussed about the basic Hive, and over there the main agenda is to get the familiarity with Hive, like how the Hive is functioning, how we will be able to create the tables, the different types of tables in Hive, how to insert the data. Okay, certain queries from the Hive perspective, like say lateral view and other like insertion of the records. Okay, moving the data, certain stuff from the metadata perspective. If we are going to drop the managed table, then what will happen? If we are going to drop the external table, then what will happen? So those particular things we have seen inside the basic Hive. Moving further, the advanced Hive, friends, that we have started. Advanced Hive is nothing but over here we are looking for the optimization. Okay, and what we have discussed in yesterday's session, that the optimization can be applied onto three different levels. Once we are creating the tables, second, once we are applying, or once we want to fetch the data from the created tables, and third one is syntactic sugar, that is nothing but certain boilerplate code what we are going to paste. Okay, why I am saying boilerplate code? Because like we are just based upon our data, we are just putting certain default code in order to increase the readability, so that the the developer's life will be easy. So that is nothing but simplifying the query structure. Over here we are going to apply certain functions or certain things which are required in order to improve the readability, and these particular things are good for the developer's perspective. These are not going to increase or add certain optimization, but these are good to have. Okay, now let me pick first optimization while creating the tables. Okay, so before moving with this, let me try to give you certain insight. So friends, what is happening? Once we are going to create certain tables on top of a particular data, and once the table is created, then what we need to do, we need to fetch the data from that particular table in order to perform the analytics. Okay, so say if we are having one table and that table is having 1 million records, and I want to find out one value from that particular data, then what I need to do, I need to scan the records. Let me write it down over here. One table is there, and one table is there, and it is having 1 million record. Okay, 1 million records are there. And records are in this particular way, say employee ID, or let me take the population data. Okay, say we are having Aadhaar number in India, Aadhaar ID or Aadhaar number, what I can say, or let me say Aadhaar ID, then name, or what I can say first name, last name. This is the schema, what I can say, last name, then age, date of birth. Okay, and state, tehsil, village, or city, and then address. So this is the data what I'm having with respect to Indian population data. India, India's population data. I'm having this particular data, okay, and say this particular data is having say 1 million record. I'm moving hypothetically. I'm not moving in the proper way. Say like 144 crore records are there. I'm saying say 1 million records are there, and you can say, let me remove it. Say population data is there. Okay, so we are having certain population data, and in this particular population data, these are the columns: Aadhaar number, first name, last name, age, DOB, state, tehsil, village, city, or address. So this is the schema, or these are the columns of my table, or these are the, you can say, fields in my table. Now if I'm going to get the value, if I'm going to say Aadhaar number 1234, this is a one Aadhaar ID what I'm having, and the name is say Pankaj, let me mention Pankaj, okay, say Changra, and age is say 39, DOB say I'm not having DOB, state say Haryana, तहसील से गुड़गांव and village से गुड़गांव. Okay, address is say 121 first floor. Okay, so this is the first record, and in this particular we are having 10 million 1 million records in this particular data, in this particular population data. Now if I need to find out one record from this particular data, then what I need to do, I need to scan all 1 million record. Okay, it might be possible we are having multiple entries with respect to this particular Aadhaar card. It might be possible. We can have dummy records. You can say, like, if this is the orders table, one customer can have multiple orders. Okay, are you with me so far? All of you?
Yeah,
Perfect.
yeah, sure.
Okay, so what we need to do, we need to scan the entire data. And you can imagine if we are going to scan 1 million records from a particular table, that will take too much time, or the latency will be very high. So what we need to do, is there any way by which I can split this particular scanning? Okay, and I will be going to scan small amount of chunk, and from that particular chunk I will be able to fetch that particular record, right? So say if I'm having uh, the state information, okay, say state is Haryana, and say if we are having 28 state in India, and right now we are scanning in all 28 states, but is there any way by which like I will be able to scan only in Haryana, and say in Haryana we are having say uh, 1 lakh record, instead of 1 million, I'm going to scan 1 lakh of record. So the scanning has been reduced. Scanning is nothing but searching. You can think in this particular, you can take scanning as nothing but searching. Okay, so the main agenda is to reduce the amount of scanning, or reduce the universe of scanning. What I'm mentioning universe, like the entire data set, if we are able to reduce that particular universe, then we will be able to minimize the latency, and we will be able to fetch that particular record. So the design level optimization, or the tables, once we are going to create, we are going to add certain optimization that is going to reduce this amount of scanning, and we are going to learn that particular thing. So for this particular stuff, what we are having optimization while creating the table, and it is of two types. First one is partitioning, partition, and second one is bucketization. partitioning, and let me. So partitioning and bucketization, that is the stuff which is utilized in order to reduce the amount of scanning. Hmm. Okay. So partitioning is nothing. Say if I am dividing the data, if I'm able to partition or divide the data into smaller chunks based upon the state, so we will be having 28 chunks. We will be having 28 partitions from this population data. And if I'm going to select, if I'm going to search the record from the Haryana partition only, then I will be able to reduce the amount of scanning, right? Or say if we have done the partitioning based upon say this tehsil field, then further probably like we will be having say 10,000 records only in this particular field, right? So we are able to reduce the universe of scanning, and that is providing us again in terms of latency. We are able to scan in less amount of data, and that is our job, right? So the main agenda is to reduce the amount of scanning, and if we are able to reduce the amount of scanning, that is simple, like if we are searching a record from 1000 records, okay, then it is taking less time if we are searching one record in 1 lakh record or 1 million record. Fine so far, all of you?
Yes, yes. Clear.
Okay, all of you. I want the buying from all of you.
Yeah, yeah. We good. We got it.
Yeah, yes, Ashok.
Yes, sir.
Perfect. So we are going to reduce the amount of scanning. So partitioning and bucketing, both of these uh, techniques are working onto the same principle. Working, these two techniques are working on same principle. Same principle, that is divide the data into smaller chunks. Okay, this is the principle, what I can say. Divide the data into smaller chunks. Now, now, uh, once we are loading the data in Hive tables, so what is the structure where the file is stored inside the Hive? We are having user. What is the absolute path? Hive, user Hive. Then where the table is stored in Hive?
Warehouse.
Warehouse. Then
Then DB.
db. Okay, say
Hmm.
database.db. Okay,
And the
then
pa- file
table
name.
name, right?
Right.
Table name, and then what we are having? We are having partitions, partition data. Okay, uh, structure without partitioning. Structure of a Hive table without partition. Without partition, and then we can verify this, so from where we can check it? inside we can go through with this name node, SDFS name node. Over here we are having utilities, then browse log, browse the file system. Okay, then inside this what we are having, user Hive warehouse and say bash 32, and just focus like we have created certain tables inside bash 32. So bash 32 is having certain tables. Okay, so bash 32 is having this like user Hive warehouse is having this bash 32, that is the database, and over here we are having these particular tables, and these are nothing like mobile phone one map and mobile phone struct. These are the tables what we have created in our uh, yesterday's session. Okay, and if I'm clicking onto this, I'm able to see mobile phone.csv. That is nothing but say CSV file. I have loaded the CSV file in this particular table. Okay, so over here what we are having partitions basically. If we are having partitions, just have a look. If we are having certain another table where we have not loaded, say orders, so just have a look. This is nothing but the partition. So user Hive warehouse bash 32, that is the database. Orders, this is the table what we have created inside the Hive, and you can check it. You can check it over here. Okay, so show tables. Show tables. Okay, and having orders table over here. So orders table, and this particular table is having what? It is having partitions related information, and that is nothing but the actual data. If we are clicking onto this and if we are downloading this particular data, so we will be having the records which are available in this particular table. So what I'm mentioning, this is nothing but the structure once we are having a table without partition. But once I'm going to create the partitions based in this particular table based upon a particular column. So over here friends, you just need to take a call. You need to do the partitioning by utilizing your mind. It is not like blindly you can do the partitioning based upon any column. You need to select a particular column from this particular data and do the partitioning based upon the column where you are going to run the queries again and again and again. Say I'm going to get the data, I'm going to query the data based upon state. Then definitely you need to proceed to to apply partitions based upon the state column. It is not like you are going to perform the partitioning based upon village or city. Okay, so you need to apply, you need to do the partitioning intelligently. Okay, you need to utilize your mind, you need to use your mind in order to do the partitioning based upon a particular column. The main agenda, do the partitioning based upon the column where you are going to write or where you are going to fetch the frequent data. Based upon the column you are fetching the data frequently, what I can say. So you need to do the chunks of this particular table based upon the column where you are querying frequently. Okay, so at that moment once you are having partitions, so this is table name and then partition information. Partition, these are nothing but say partition files. Okay, partition files. So once you are having, once you are going to apply the structure, once you are going to apply the partitioning onto a particular table, then what will happen, the structure will look like this uh, with partition. So the structure we will be like this, say partition folder. We will be having say if we are performing the partition based upon say state, so say the partition is based upon state. So we will be having the folder state equal to say Haryana. Okay, then we will be having the partitions in this state equal to say Uttar Pradesh. Okay, then state equal to say MP, Madhya Pradesh. Okay, and then we will be having part files, part files, part files, part files. So what we are able to see over here, so like 6 times 0 underscore 0, this is nothing but the data. Okay, so that is nothing but the part file or partition file. This is nothing but the partition file. Like over here the block size is 128 MB. If like we are having the file which is having a lot of records, then we will be having multiple partitions over here. But what will be added, the another directory or folder will be added, that is the partition folder basically, and it will be having the data with respect to this particular state. Okay, so we have done the partitioning based upon state, and all the records will with respect to the Haryana state will be available over here. All the records with respect to the Uttar Pradesh will be available over here in this particular part file, and all the records with respect to the Madhya Pradesh will be available in this particular file. So these particular files will be carrying the records with respect to each and every state. But over here, these particular part files are having records of all the states. State information is not available. Inside the partition file, we will be having that particular information. Now, just have a look. So over here, once we were searching a particular record, then we were scanning all the files which are available over here in this particular table. But once we have done the partitioning, we are picking a particular folder. Say with respect, if we are searching, if we are looking for Uttar Pradesh, then we are going to select this particular folder, and we are going to scan this particular file only. Others will not be scanned, and this is nothing but reducing the amount of scanning. Are you able to see with respect to this particular structure? Are you able to visualize what is happening internally?
Yeah, so
Okay, so physically these particular files are available, and in this particular way the amount of scanning is reduced. Okay, the amount of scanning is reduced. Over here we are scanning all the records. I'm repeating it once again. Over here we are scanning all the records, but once we have done the partitioning, we will be having the partitions based upon the column, based upon the data which is available inside this particular column, which will be equal to the elements available in this particular column. Say if we have done the partitioning based upon state, then we will be having say 28 partitions. So over here 28 partition, 28 folders will be there. And based upon those particular folders, like those are nothing but the state information. If I need to get the records from Uttarakhand, then that particular partition will be scanned. Rest others will not be touched. Okay, so that is the beauty of partitioning. With utilizing the partitioning, we are able to minimize the amount of scanning, and this is pretty simple. Over here, if we are having partition files, then we need to scan all the records from all the files. We are not having any mechanism to select a particular record by scanning just few records if we are not moving with partitioning. Okay, but once we are moving with partition, we are having a mechanism to reduce the universe of scanning, and limited amount of data or partitions are scanned, and that is able to minimize the latency, right? Are you able to visualize? This is pretty simple. If I'm saying that you need to provide me the information from you need to provide this particular data by scanning all 28 states, okay, or by scanning the entire data, then definitely you will take more time. In comparison, if I'm saying you just need to scan in this particular partition, so that will be having less amount of data, and that particular scanning will take less time, right? Fine so far, all of you. This understanding is very much important, huh? These are basics.
Yeah.
This one, understand, Ashok. Just a one question here, like if we are taking the example of this data, okay, based on we did the partition like in the state. So, is there
Hmm.
any possibility? Can we put the inside the Haryana? Can we put the based on the district inside the Haryana? Can we do the? Is there any possibility?
Yes, definitely you can do. So you can take it in this way. In Windows, we are having folders. Huh? Okay, we are having folder. Can we create a folder inside another folder? Okay, I'm having say Hive. This is a folder.
Hmm.
Can I create a folder over here?
Yes, yes, you can create.
Okay, so if we have done the partitioning based upon state, that is nothing but a folder. Just try to think logically. Yeah, we are having a folder. We can create another folder, so we can have partitioning based upon the two columns. That is pretty
Mm-hmm.
simple. Okay,
Mm-hmm.
and
Mm-hmm.
that that is further going to reduce the amount of scanning. What you can do, like say over here, say tehsil. Based upon the tehsil, I'm going to do the partitioning. So tehsil is say equal to Gurgaon. So that is let me try to copy and paste it for the better visibility. So what will happen at that moment? So say another partition tehsil, and tehsil equal to say Gurgaon. So it's partition file, okay, and it will look like this. I will show you once we are moving with practical, but before moving with practical, I just want to give you the insight what is happening. So tehsil Panipat, part file, tehsil se Hisar. Okay. So in this particular way, what we are doing, we are further reducing the universe. Okay, we are further reducing the universe. Over here, it will select the records from the Gurgaon only. It will select the records from the Panipat uh, district or tehsil, what I can say.
Mm-hmm.
Okay, so and over here it is going to select the records from Hisar only. So in this particular way, the amount of scanning is further reduced. Okay, but you need to focus, you need to pay attention while selecting these particular columns. Okay, so if you just need to, it might be possible based upon the data. Uh, mm, hmm, say I'm having employee table, or I'm having say sales data, sales data, and sales data is having say sale ID, sale ID, and date, and say uh, category, and amount, date, category, amount, and mm, or I can say quantity, quantity, rate. Okay, okay. So rate. So we are having these particular columns, and this is data. This is a data, and like customer wants the outcome based upon data, like what is the total sale amount for this particular data. Okay, what is the total sale amount for this particular data. Now you are having category information, and suppose you have done the partitioning based upon category, but in order to query, like say select date, or select what select sum of this amount as total amount from sales data, group by what, group by say sales id, not sales id. Okay, say sales id, or group by data, or let me group by data. So over here, group by date, so it is going to provide you the outcome based upon the date, and it select date as well. Select date and sales id, sum of amount, and let me remove this sales id as well. There is no need to have sales id. Okay, so I'm going to select date, sum of amount from this particular sales data, that is a table, and I'm going to like have this particular, the customer is willing to have this particular data. Now in this particular table, if you have done the partitioning based upon category, okay, then like there will not be any gain based upon this particular category. Like after once we are performing the partitioning based upon category, then it will not provide us a gain. What we need to do, we need to do the partitioning based upon date at that moment, based upon date. So you need to choose the column based upon from a particular data, okay, based upon the query, like the the frequent query is based upon which column, so if a particular column is having high number of querying frequency, then we need to select that particular column for partitioning or bucketization, right? For partitioning, it is not like say we are having a lot of columns and we have selected a particular column on which we are not performing any query. That will not provide us any gain. Are you able to get?
Can you repeat
Are you
once
able to
again?
get?
Sorry,
Okay. Okay.
I understand the query, but I forget.
Okay. So
Just
if
repeat, please. Sorry.
okay. So if just try to like uh, think with respect to the physical structure. So physical structure for this particular table, what it will be? It will look like say table name, that is nothing but the sales data, and then what you will be having? You will be having, say you have done the partitioning based upon category, say category equal to say electronics, electronics, and say part file. Okay, then what you are having, you are having another category, say category equal to say games. Okay, part files, category equal to say clothes. Okay, Okay. So now the data will be available physically in this particular format onto the disk if you have done the partitioning. Now I am going to query onto this particular data. So this category, it might be possible it is having different dates. Okay, this electronics date, it might be possible it is available in games, it is available in clothes, right?
Mm. Right. Mm.
Try to visualize, try to visualize. Let me show you with an Excel as well. Okay, try to think logically. Okay, so I have given these particular columns. Say sale ID, sales ID, sales ID, date, and then what? Category, amount, and say quantity and rate. Okay, so sales ID say 1, date is say so 12th March. Okay, and category is say electronics. Okay, and amount is say 40, quantity is say 2, rate is say 30,000. Okay, amount is equal to this one, this into this. Okay, so this is for say category, and you can add certain column with respect to say what you have purchased. I have mentioned the category only. Now say we are having sales ID 2. Okay, and say 12th March, and we are having category say clothes, and say the quantity is 1 and 200. Okay, okay, so another category what we are having say on to this particular date only, say we are having games. Okay, and the amount is quantity is 10, amount is say 400 in this particular way. 12 13 March. Let me try to copy it. Okay, say we are having this particular data, right? And the query is being done based upon the data. Now you have done the partitioning based upon this particular category. Now what will happen? Say if you are selecting say electronics. So what we are having electronics categories available in say 12th, 13th, 15th, and 18th. So what we need to do, if we are going to query based upon date and we have done the partitioning based upon category, then what will happen over here? I need to scan, if I have done the partitioning, even though I need to scan the data records from the all of the partitions, right? I need to scan over here, I need to scan over here, I need to scan over here. If I am querying based upon category, then that is fine. I am going to select this much of records, like if electronics category is there, and I will be able to get the outcome. But the query is being done based upon date, so I need to search all the records, because this particular date, okay, like say 12th March, 13th March, 15th March, and 18th March, it is available inside all the categories. Okay, this date is available in games as well. Okay, these particular dates are available in clothes as well. So I need to scan the entire data set. Are you able to
Yeah, right,
get?
right. Mhm.
Okay. So what I have mentioned, you need to choose this particular partition column wisely. It is not like you are querying based upon date and you have done the partitioning based upon category. That is not making any sense. It will not provide any gain. Fine so far?
Mm.
Gaurav,
Yeah.
Rohit,
Yes,
Rakesh, Naresh.
Yes, clear.
yes, sir. Yes, got it.
Perfect. Huh? So you need to use your mind in order to do the partitioning based upon the column where we need to perform the frequent query. Okay, where we need to get the data frequently. So that is what we are able to see over here with respect to partitioning. That is pretty simple. Huh? Just we are dividing the data into smaller chunks, and these particular chunks are created based upon the column on which we need to perform the query frequently. Okay. Another challenge what we can have once we are applying partitioning, that is the cardinality. Okay. Cardinality. Yeah. So this is a main term and you need to explain. It might be possible like someone is asking what is partition. Okay. On which column you are going to perform the partitioning. So cardinality is a key. Based upon that you are going to do the partitioning. So over here you need to do the partitioning based upon the column where you are having low cardinality. Partitioning is done once we are having low cardinality or done on a column which is having low cardinality. What is cardinality? Okay, so if you are able to see in this particular data set, sales id is what, like these are nothing but the unique items over here, say sales id 1 2 3 4, and over here the category, that is electronics, cloth, or even date. Okay, so once we are having high repetition, high repetition of the elements, high repetition of element in a particular column, that is denoting low cardinality. Or if I'm going to say apply distinct operation over here, we will be having say the count 3 only, and if we are going to apply distinct onto this particular sales id column, then we are having 13 or 10 records. 10, the value is 10 if we are going to calculate distinct onto the sales id, right? Are you with me, all of you? If we apply distinct onto sales ID, then we will be getting 10. If we apply distinct onto the category, then we will be getting 3 as an output, right?
Right, sir. Right.
Right, Ishu.
Okay, guys, please be interactive. It is motivating me. So if we are having low distinct count, that means we are having low cardinality. If we are having high distinct count, then we are having high cardinality. And you can imagine, you can think in this particular way. Say if we are having India's population data, what we have seen over here. Okay, so Aadhaar id, that is nothing but a unique number which is allotted a particular person, and the state, tehsil, and the village, city, these are nothing but, if we apply district operation over here, we will be getting less, you can say, value if we are applying distinct over here, so that means these particular columns are having low cardinality and the Aadhaar ID is having high cardinality. So this particular partitioning is applied once we are having low cardinality. Okay, low cardinality. And why so? If we are doing the partitioning based upon the say sales ID, yeah, you can think in this particular way. Say if I have opted the sales ID in order to perform the partitioning, then what will happen? I will be having 10 partitions, or I will be having 10 folders. 10 folders, it will be like this. Say this is the data. This is the data. Let me copy and paste it over here. Okay, this is the data. And if I'm going to perform the partitioning based upon the sales ID, so how it will look like? It will look like in this particular way. User Hive warehouse DB sales data and sales ID, sales ID, sales ID 1. Okay, so in this particular way, I will be having 10 folders because I'm having 10 records only. Yeah? So 2, 3, 4, 5, 6. In this particular way, I will be having different, you can say, folders. Now, once we are having the partitions in this particular way, once we are having partitioning in this particular way, and suppose I'm searching say select star from the sales data where sales ID equal to 1, then definitely like we will be having a lot of partitions over here, and I'm going to select this one. Okay, I'm going to select this one only. Okay, but the main challenge with this particular approach, what it will be, the name node, the master node need to maintain a lot of metadata. It is not like we will be having 10 records only in actual working environment. We will be having billions of records. And once we are having billions of records, then billions of partitions will be available, will be created. If you are going to create the partition based upon the high cardinality column. Okay, so what you need to do, you need to pick a particular column which is having low cardinality and proceed with the partitioning with that particular column with the condition that curing is being done on that particular column. Okay, so we need to proceed with partitioning with a column which is having low cardinality. Then there will be a question. Okay, what to do when I will be having high cardinality? Okay, what to do? So for that, what we are having bucktization. So bucktization is the solution once we are having high cardinality. Okay, fine so far. Just have a look and ask if you are having any doubt. Up to so far, is it clear with everyone?
Yeah, clear, Ashok.
All of you, I want buying from all of you. Is
Yeah,
there
so
any
I
challenge?
think
Mm-hmm.
no, no. What I'm saying that if we are going with the low the term cardiologist, I forget, but we can go with
Hmm.
this one, low one. I think bucketization is not required in that case, or that case also required.
I will come on that point. You just need
Uh-huh.
to
Yeah, yeah,
be
right now it's
specific
clear
with
for
the
me.
query. Like if you are having high cardinality, then partitioning is not the solution for that. Okay. High
Okay.
cardinality, then partitioning is not the preferred solution. For that, we will proceed with the buctization. Okay. And what is buctization? What is happening inside the buctization? That we will see.
Okay, got it.
Now, if we are talking about partitions, we got like enough understanding from the partition perspective. That is nothing but dividing the data into smaller chunks, and these particular chunks are based upon the column on which we are going to perform the frequent query. Second, it is based upon the column where we are having low cardinality. Okay, so points to remember. Number one, partitioning is being done on a column where cardinality is low. Second, the column must be taken wisely, and we need to do the partitioning where queries or partitions on a we need to we need to consider the column on which query is performed frequently. Okay, fine. Now that is fine. These are the 2 points in order to apply the partitioning, but the partitions are of two types. Partitions 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 are of two types. Static partition and dynamic partition. Static partition and dynamic partition. Okay, static partition and dynamic partition. Now static partition and dynamic partition. Once we are having static partition, okay, so static partition, once we are going to like when we need to apply static partition and when we need to apply dynamic partition, or what is the betterment that we can get with static partition and dynamic partition, which one is better, what I can say. So two types of partitions are there: static partition and dynamic partition. Static partitions, over here we are having the complete understanding, complete information, what I can say, complete information about the data set that we are dealing with. uh, we are having the information about all partitions, that we need to create, and it requires manual intervention. Okay, what is the meaning of this? So in this particular data set, just have a look. So we are having this particular data set, and in this particular data set, say we are going to perform the partitioning based upon the category. Let me take an example. So we are going to perform the partitioning based upon the category. So if we are looking onto this particular data set, how many partitions we are going to have? Three partitions, right? We will be having three partitions, right?
Yes, yes. Right.
Okay, so over here we are going to define the partition manually. Say the category equal to electronics, category equal to clothes, category equal to games. We manually define these particular partition. Okay, so these particular partitions or static partition is performant in nature. These are able to execute in less amount of latency. Okay, these are performant one. Performant one means performant ones, because these are able to execute within less amount of time. Over here we are instructing the system that these are the partitions and you need to dump the data based upon these particular partitions. We are instructing the system, we are instructing Hive, these are the partition that we are having in this particular data. And once the Hive or the system is able to get the information that these are the partitions only, okay, so it will be able to do the execution with less amount of time. And that is nothing but like if latency is less, then we will be able to execute it faster. And if something is executed faster, then we will be having low latency, or though that particular stuff will be the performant one. Okay, so because of that particular stuff, because we are instructing system to dump the data in these particular partition only, so because of that, it is the performant one. Static partition, we are talking about static partition. But there is a challenge, and you need to tell me what can be the challenge. Static partition is having one challenge, and you need to tell me. All of you are dealing with huge data set, okay, in
If new
your
categories come, then we need to create it again.
huh definitely, yeah. So we are not having the information about this particular category. Okay, if we are having billions of records, it will be very tricky. It will be very tedious task to define all the partition manually. Okay, even though we are having the information. Okay, and if a particular category is new, or it might be possible, say we are getting the data from a particular say we are getting the we are working on the population data, so it is fine. Say we are working on to the India's population data, say states are 28, that is pretty fine, pretty simple. We are having that information, like 28 states are there. But what will happen if we got the data from Pakistan or Nepal or say US or England? How many states are there? We are not having information. So we will get the data. We know that we need to perform the partitioning based upon state. Okay. But we will not be having the exact information about all the partition that we need to create, or the data is hidden in nature, what you can say. So if the data is hidden, or if like you are not having the awareness about the data, second, if you are having the awareness as well, but it will be very tedious to define all the partition, because it requires manual intervention. I have mentioned over here, it requires manual intervention. You need to define the partition manually. What we are mentioning over here, okay, so you need to define these particular things manually. But once we are having dynamic partition, we just need to mention that I want the partition based upon this particular column, and it's the system responsibility to to check that particular column, to check the elements which are available in that particular column, and proceed with the partitioning. Because of that, like system over here needs to check how many partitions I need to create. So in that direction, the dynamic partition is taking some time, and because of that, it is less performant if we compare it with static partition. Dynamic partition. Okay, over here we are just mentioning the column based upon what we want to have partitions, and then system will decide how many partition it needs to create. It's need to create. Okay, it needs to create. Because of that, it is less performant than static partition. And it is important from the interview perspective as well. Let me mention over here. Okay, that is important from the interview perspective. Okay, what is static partition, what is dynamic partition, what is partition, what is bucketization. So if you are going to mention like you are working with Hive, you are having enough understanding to work with Hive, then definitely some questions will be there from the partitioning side. Okay, so dynamic partition and static partition, is it clear to everyone? I want buying from everyone.
Yeah, so
Yes, yes, sure.
Yes, yes, yes.
Okay, sir.
Perfect, perfect. Okay, now I'm proceeding with the dynamic partition. Sorry, bucketization. So up to so far what we have seen, two things, like the cardinality is low, we are proceeding with partition, and partition is going to provide or create a folder, and in that particular folder we will be having part file. It is of two types, static and dynamic, and static is the performant one because over here we are instructing system to to dump the data into these partition. But apart from this, like dynamic partition is there where we are just mentioning the partition column, and it's the system responsibility to choose or to create the number of partition and dump the data, and because of that it is less performant. Moving with bucketization. So the challenge with partitioning, that was like if we are having high cardinality means we can't create. You can think in this particular way. Say you are having data, you are having say CM data. Okay, configuration man, or like say PM reports are there. You are having PM reports. So PM reports are there, and say you are having the data that is bucketized, or sorry, that is partition based upon the RNCs, and then further you are having sites and cells. Okay, and based upon say if you want to perform the, if you want to get a particular cell, and you know that is available in this particular RNC, so you are just going to scan that particular RNC, and in that particular way you are able to minimize the latency. Now suppose if you have done the partitioning based upon cell ID, then there will not be any use. You are just going to increase the metadata or the load onto the master node or name node, and it will not provide the gain in that direction what we want. If, like over here we just need to scan almost all the records, like if the scanning is being done or if the querying is being done onto the different columns and all. So that will not provide again. And why so? Because we were having high cardinality. High cardinality means cell id is nothing but the unique, say, uh, key or the primary key, like stuff inside the pm data. Now we want to do the analysis based upon that, and we want to minimize the latency. We just want to reduce the amount of scanning or universe of scanning. So bucktization is the solution once we are having high cardinality. So over here, what we are going to do in bucktization, say, just try to think. Say we are having 10 million or say 10 million records. 10 million records. Okay. And I can take that particular example, say Aadhaar wala. Okay. This data set is there. Okay, now what I just want to query based upon the Aadhaar ID and all. And if I just want to perform the analysis based upon Aadhaar ID, I just need to query based upon the Aadhaar ID. Say select star from this particular population data where Aadhaar ID is this one. Okay, if I want to perform this kind of query, then what I need to, let me mention the query. Select star from pop data where Aadhaar ID equal to, say, this one. Okay, so if I want to perform the query in this particular way, and partitioning, or over here the cardinality, definitely Aadhaar ID column is having high cardinality. Okay, so in this particular way, we know, oh, if the cardinality is high, then partitioning is not a solution. So what I have mentioned, bucktization is the solution for that. So what exactly is happening over here inside the bucktization? So over here, I'm going to divide the records. I'm going to divide the records, or I'm going to divide all the records into smaller chunks. Okay, and how many chunks, that is decided by me. Okay, so I'm going to divide the data which is available in this particular table, okay, based upon this particular, say, based upon the Aadhaar ID column into multiple chunks or smaller chunks. Okay, over here that is a chunk. Say 10 million record, that is nothing but a chunk, uh, a set, or the group of records. So I'm going to divide into smaller chunks. Say I have decided to divide it into the 10 chunks. So 10 million is there. So 10 million is divided into million, is divided into, say, 10 chunks, and say 1 million, uh, in this particular way I will be having, say, 10 chunks of 1 million. Okay, 1 2 3 4 5 6 7 8 9 and then 10. Okay, so 10 chunks of 10 chunks of 1 million each. 10 chunks of 1 million record each. Okay, so what I have done over here, I am going to divide the data into smaller chunks. And how many chunks I need to have? How many chunks I need to have? How many chunks I
10,
need to have?
10.
But like 10 is given by me. Say if you are going to divide 10 million, then are you going to divide into 10 chunks? It might be possible you are dividing it into 20 chunks, 30
Right,
chunks, 50 chunks, huh? Right?
right, right.
Okay. So that is a you can say bottleneck kind of thing over here. Try to focus, huh? I'm providing you certain insight, huh? So what is happening, friends? Once we are having bucketization, then we are going to divide the data into smaller chunks. How many chunks? That is not fixed. That is not fixed. It is decided by experience only. Okay, it is decided by the knowledge of data set. Okay, it is decided by the benchmarking that you are going to perform onto top of that particular data set. Okay, let me repeat it in another words, huh? Say at this moment I divided this particular 10 million records into 10 chunks, and then I will proceed with the analysis onto top of this particular data. Okay, slowly, what I observed, like the query is taking too much time. Okay, then what I can do, I can either increase these particular chunks or I can decrease. Okay, you can think like in telecommunication, what we are having different parameters, huh? We try to increase the value of default parameter, then we observe like there is certain degradation in the stat, then what we will do, we will reduce the value, and then what we observe, like there is certain improvement inside the stats, huh? Same thing is applicable over here, huh? If you are going to perform the benchmarking, okay, based upon the chunks that you have decided, and if the query is taking you need to opt a number where you are having low latency, yeah. So over here, once you are performing the bucketization onto top of a particular data, these okay, so these chunks are nothing but the buckets, huh? These chunks are nothing but buckets. So you have divided 10 million records into 10 buckets. Okay. So once you are performing bucketization onto top of a particular data, then it is not fixed like you are going to divide the data into these many buckets. Buckets will come with experience. How many buckets you want to have, that will come with experience, that will come with the benchmarking that you are going to perform onto top of that particular data set. It might be asked during the interview, like I'm having this particular data, how many buckets I can create, then you need to answer this particular question uh, hypothetically, so you just need to provide the answer with respect to the scenarios, say say if I'm having this particular records, then I will first I will try to divide the data into these many chunks. Okay, say 10 chunks, 10, if I'm having 10 million record, so I'm going to divide it into the 10 chunks. But then further I will try to proceed with the benchmarking and all with the different chunks and all, and the number which is providing me the low latency, I will proceed with that particular number. Okay, so you need to provide the answer in this particular way. There is no fixed number that, but this particular data is divided into these many buckets or these many chunks. Okay, so over here I'm going to divide the data into smaller chunks, and these chunks are nothing but the buckets. And how many buckets I need to have? Many buckets I need to have, that will come with experience, knowledge of your data. or understanding of data set and benchmarking on number of buckets. Okay, number of buckets. Okay, so let me try to give you certain more insight about buckets. Okay, so we are having, say, this particular data. Just try to focus. We are having this particular data. So this particular data is there. Let me paste it. This particular data set. And what we have observed, like we need to proceed with the bucketization because we are querying based upon the sales ID column. The concept which is mentioned over here with respect to the partitioning, oh, partitioning is being done onto a column where on which we need to perform the frequent query. Probably I have mentioned somewhere. Hmm. Over here I have mentioned now the column must be taken wisely. We need to consider the column on which the query is performed frequently. So same clause is applicable over here as well. And based upon that clause, we are able to get the sales ID is the column where we are performing the query frequently. That is perfectly fine. Now we need to proceed. We are checking. Once we have checked the cardinality, we have observed the cardinality is high over here. So if the cardinality is high, then partitioning is not the solution. So what we are having, we are having bucketization. Now on this particular data, okay, how many buckets I am going to create? We are having 10 records only. So how many buckets I'm going to create? Tell me any number. How many buckets I am going to create over here? I can create over
I
here.
think one is sufficient.
Hmm? But one is one
And
is
only
not
for 10
sufficient
record. Only 10 record, na?
because we need to reduce the universe of scanning. Don't think like we are having 10 records only. Okay, you can think in this particular, say we are having 10,000 records. So these are the 10,000 records. One is representing say 1,000. Okay, so the main agenda try to think in this particular way, like you need to reduce this particular universe. At this moment we are scanning all 10 records, and is there any way by which I will be able to reduce the amount of scanning? So bucketization is definitely a process with the help of what I will be able to reduce the scanning. But how many buckets I need to create?
Like if 10,000 records are there, we can divide it into 10 containing 1,000 each, or in
Hmm.
5 containing 2,000 each.
Okay, so if 10
Uh,
records are there, then
then
how many buckets you
then
are going to create?
then two or three.
Uh-huh. Tell me one number, two or three.
Two if we go
Two.
with two.
Okay. So I just want the number from each one of you. So I think Gaurav is saying two, huh?
Rohit.
Rohita. Gaurav, what is your number? How many buckets you want to have from these 10 records? Vikas, Naresh, Rakesh, give me a number, huh? So as per Rohit,
Three,
two.
three.
Vikas, three. Okay. Gaurav, Naresh,
Three, sir, three, three.
three. Okay. Rakesh,
I think it should be three.
Okay. So over here, like 2 and 3, that will not create any problem, to be very frank. It will depends on you. If you are going with the two, okay, two buckets, then uh, how it will be, we will be having first bucket that will having this much record, and the second bucket will have this much record. If we are moving with three, then we will be having first bucket and the second bucket and third bucket. Okay, that is perfectly fine. Like we are going to divide the data into this particular way, but over here, which record is moving to which bucket, which record is moving to which bucket, that is decided by internal function like modulus division. Modulus division, that is like the simple function which is working internally in order to move these particular records in a particular bucket. So if the bucket is 2, if say bucket is 2, okay, then what will happen, the record, say record, the sales id modulus division by 2, modulus division by 2, 2 is the number of buckets. So modulus division, what is the remainder over here? Remainder is 1, right?
Right.
If 1 is then it will move to first bucket. Okay, and then the 2 divided by 2 modulus division 2, 2 is this particular sales id, then remainder is 0, so it will move to the 0 bucket. Okay, if we are having record number 3 modulus division 2, the outcome is 1, and it will move to the bucket id 1. Same fashion, the record is 4 modulus division 1, 2, then outcome is 0, it will move to the 0th bucket, bucket with id 0. In the same fashion, the record like the sales id 5 modulus division 2, outcome is 1, it will move to the first bucket. Okay, so bucket 0, that is the bucket id 0, and bucket 1, that is bucket id 1. This is the first bucket id 0, and this is the second bucket. Now based upon this particular internal function, that is nothing but the modulus division, the records are moved in a particular bucket. So over here modulus division is the function which is deciding which record is moving to which bucket. Now what will happen, in this particular way we'll be able to see the movement of record. And if like we are having 3 buckets, then it will be like uh, modulus division 3, the outcome is 2 1 2 0. Okay, so first bucket, second bucket, and 0th bucket. Okay, 4 divide modulus division 3 3 3, and 1 2, and then 6 divides modulus division 5 6 6 modulus division 3, outcome is 0, it will move to the 0, move to the second bucket, one bucket. So if you are having 3 buckets, then the movement will be happening in this particular way, right? And just try to think, so what we have done, we have logically divided these particular records into buckets or chunks. Then in this particular way we are going to reduce the amount of universe or amount of records, because previously we were selecting if the buckets are 2, previously if the bucket, if like no bucketization is there, we are scanning all 10 records. But if we have done the bucketization and 2 buckets are there, then we are scanning in 5 records only. The universe is reduced, right? The universe is reduced based upon the bucketization, based upon the high cardinality column. Fine so far?
Right.
All of you,
Right, sir.
are you able to get, huh? Rakesh,
Yeah,
Gaurav,
got it.
perfect, huh? So we are able to reduce the universe, the size of universe, by reducing the number of scanned record, and with the help of bucketization we are able to do that, huh? Now bucketization, if we are going to perform the bucketization, how it will be looking onto the warehouse side, huh? So bucketization is going to create a file, file in file structure or in Hive structure basically. Okay, so Hive structure is user, Hive, warehouse, DB, sales, and then what we will be having, say bucket 1, bucket 2. Okay, so these are nothing but the files are there, huh? So this is not a folder, this is a file, bucket 1, bucket 2, bucket 3. In this particular way I will be having different uh, files, which will be having the records based upon the modulus function, modulus division, what we are having. So bucketization is going to create a file inside the Hive structure, and partitioning is going to create a folder. Now you need to tell me, can I have can I have partitioning inside the bucketization? Okay, can I have partitioning inside the bucketization? So say bucket 1 is there, and further I can do the partitioning, say based upon, say partition, or partition, say category, and category equal to say electronics, huh? Can I do partitioning inside bucketization?
Yes, it can be done.
Ah,
Yes, it can be done.
okay, what about
Yeah,
other?
I think yes, we can do.
Yes, it can.
Okay, so what I have mentioned over here, bucketization is going to create a file. Can a file, can I create a folder inside a file?
No, no, no.
Huh?
No, a folder cannot be created inside.
So bucketization, inside bucketization I can't create partitioning, but inside partitioning I can create bucketization, right? This is a very important concept, huh?
Hmm.
So inside partition I can create buckets, but inside buckets I can't create partitions, and I can create partition and bucketization together on top of a particular data. Okay, so what I can do, I can I can do partitioning onto this and this, and I can further do bucketization onto sales ID in order to optimize this particular query further. But I can't move in this particular way. Say I have created bucketization and then I'm looking for partitions. That is not possible. Okay. So inside bucketization, inside partition, I can create buckets, but in buckets I can't create partition. Simple concept, huh? And that's why like I have mentioned the folder structure. Huh? Okay, at each and every state or stage I have mentioned this particular physical structure, huh? How the file and the partitions will be looking, will be visible inside the Hive file structure. Huh? What will be the physical structure? Huh? Okay, this is important one. Huh? Okay, that can be asked during the interview. Huh? Okay, now I will walk you through with the differences between partition and bucketization. So difference between partitions and bucketization. So what I can mention, partition over here, and over here I can mention the buckets. So you need to tell me, you need to tell me, we are having enough understanding about the partitions and buckets. Now you need to tell me the differences. Okay,
Partition
tell
required
me.
manual intervention.
Okay, so but inside the dynamic, what I can say, there is no manual intervention,
Mm-hmm.
or what I can say, unknown number of buckets. Now let me proceed with the dynamic one only. Unknown number of partitions. We are not having the information. If we are performing the dynamic partitions, okay, we are getting the data, and thus we mention the column name, and the partitioning is being done, right? We will not be having the information how many partitions will be created, right? Say yes or no.
Yeah, and partition will done on where low cardinality is there.
Yes, 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 that is the another one, low cardinality,
Yeah.
and over here we are having high cardinality. Perfect. So over here we are having a known number of partitions, and over here what we are having, known number of buckets. Known number of buckets. We used to decide like how many buckets I want to have. Okay, how many buckets you want to have, you just need to decide, you just need to fix, right? If you want to have 4 buckets, then like the data will be divided into 4 chunks. If you want to have 10, then the data will be divided into 10 chunks, right? Now, and what is this one? Each bucket is a, each partition is a folder, and each bucket is file,
Hive.
right?
Right.
Right? Partitions. Now you need to tell me, if I'm performing partitions, say I'm having the India's population data and I have done the partitioning based upon state, then what about the number of records in each partition? Will it be equal or the different one? Or I will be having unequal records in each and every partition?
Unequal
Hmm?
records in each
Unequal
partition.
records. Partitions will have unequal number of records, but in bucketization I will be having almost equal number of records, because this is decided by what, the modulus division, and it is going to keep on checking each and every number, and based upon that almost each and every bucket will be having the equal records. like there might be slight difference. It might be possible, say if we have 10 records, so over here we were having 10 records, and what we have decided, we have decided 3 buckets, so one bucket is having 3, another is 3, and the last bucket probably will have 4 records. Almost equal records are there. Okay, but say if we have done the partitioning, say based upon 12th based upon date, so the date 12th March is having high number of records instead of say 18 March, which is having single record only, right? Are you with me?
Yeah.
Yes, yes, yes.
Perfect. Now you need to tell me, if someone is asking, say you are working with data science team, and data science team is doing what they are going to take a sample of the data, and they develop the machine learning algorithm on top of that particular data, and they generate the outcome, and they are going to predict something. Now if you are going to create, if you need to provide a sample, then what you are going to provide? Are you going to give a bucket, or are you going to give a partition? What you are going to provide? Partition or bucket? And you need to tell me why.
Partitioner.
Partition.
Partition. Partition. Why partition?
Because it will
We cannot share the
somehow.
complete.
Uh, you
Yeah, Rohit, you continue.
Yes, yes, please. Yeah, Vikas.
No, what I'm saying, like, we cannot share the complete detail to the team. Uh,
No, 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 no. We are going to share all the records, all the columns information, and in buckets and in partitions, the entire data set, and not entire data set, but and the complete flavor of the data will be gone. Like all the columns information will be gone to the data science team. Then they will be able to apply machine learning algorithm. They will perform the feature engineering at all. Okay.
Yeah, basically partition will provide them the information, like suppose if I call about the sale, like in this particular category, how many, what is the total amount sale has been done on how many days,
But
and this.
sample is the portion of this particular data. Sample, inside the sample, we are going to, if I'm having 100 records, and if I want say 10% records,
Mhm.
so 10% sample of this particular data, so I'm going to provide 10 records, so if this is the data set what I'm having, and if I want say 20% of this particular data, so I'm going to provide 2 records, 2 entire records, so if I am going to provide 20% of this particular data, so I can provide it with the help of bucket, and I can provide it with the help of partition as well. Are you able to get? So what I need to provide, will I move with bucket or a partition? Hmm. And partition, if you are going to provide a partition, then why you have chosen partition? Okay, tell me what is a sample? What is a sample? Sample is something. Let me provide you insight. Okay, sample is something which will provide you the flavor of your product. Okay, say ice cream vendor is selling the ice cream, and if you want a sample, so he will provide 2 to 3 ice cream which are the best selling items. Okay, that is nothing but a sample. Same thing is applicable over here. If I want a sample of this particular data, so the sample is provided in terms of bucket or in terms of partition.
Yeah, then bucket will work because bucket will contain different categories. So
Yes.
that will be
Okay,
a
it
sample
will
of
be
all the.
having bucket will be having the complete flavor, the entire flavor of your data set. If you are going to provide the bucket, so either you are going to provide electronics, cloth, or games. Okay. So if the electronic category is provided, then the analysis will not come for the clothes. The analysis will not come for the games. Okay, if say you have provided the sample of India's population data and say Goa or say Kerala is having high literacy rate, so what will happen with respect to Bihar that is having low literacy rate? The outcome will not be correct, right? So if you need to provide a sample, then bucket is the solution, and bucket is going to select the records based upon the internal function. It is not like it is referring a particular category. Okay, so it is going to select the records based upon the modulus division function which is working over here. And uh, once you need to provide a sample, then you just need to ask like uh, what is the percentage that you want. So if he is saying, say, I want to have say 25% of the sample, then create 4 buckets from that particular data and provide 1 bucket, right? Clear?
Yeah, sure. Clear.
Okay, so I think that's it for this particular session, and in the next session we will proceed with the practical, so today I just want to give you the insight what exactly is happening with respect to partition and buckets and what are the different types. So in next session we will be going to proceed with the practical, and we will deep dive in the functionality part, and we will try to see practically what we have mentioned over here. Okay, let me stop recording and take your queries.